Ladies and gentlemen, students and seekers of truth, welcome to Learning Academy Foundation from Mr. Andrea. Let me ask you something. Have you ever tried to measure how fast your dreams run away when you procrastinate? Or how long it takes for your motivation to reach the finish line after a Monday morning? Welcome to the world of motion, where everything moves except your Wi-Fi when you need it most. Let's begin with basics. Speed, distance, and time is a topic about the relationship between these three measures, as shown by the formula below. Speed equals distance over time, divided by time. Formula can also be arranged to calculate distance or calculate time given the other two measures. An easy way to remember the formula and the different arrangements is to use the speed, distance, time triangle. Let's begin. So speed is how fast something moves or is moving. It is equal to distance in meters over time in seconds, and international system units is meters per second. Distance is how far it goes. Time is how long it takes. Simple, right? So why do we still ask, are we there yet? Why does the fastest runner still take longer than my download speed? To measure distance, we use meters or kilometers. Time, seconds or hours. Speed, meters per second or kilometers per hour. So, for example, if the speed of a car is 18 kilometers per hour and it takes 4 hours for the journey, how many kilometers has it traveled? 2. Distance equals speed times time. That is 18 times 4. That is how much? 72. Correct. So if you are in a car, then speed is kilometers per hour or miles per hour or just too fast, slow down. Average speed is total distance divided by total time. Speed time equals distance over speed, and distance, as we have seen, is speed times time. If you run 100 meters in 20 seconds, your average speed is calculated as total distance over total elapsed time. So, for example, 100 meters divided by 20 seconds, that is 5 meters per second. Elapsed time equals total distance over speed. Distance equals speed times time. But if you stop halfway to tie your shoe, does your shoe get partial credit? Let's calculate. Speed equals distance over time. So distance equals speed times time. For example, a car travels 60 kilometers in 2 hours. Average speed, 30 kilometers per hour. Now, convert that to meters per second. Multiply by 1,000, divide by 3,600. Wait, why not just invent a unit called confusion per second? Graphs, the visual poetry of motion. A straight line means constant speed. A curve, acceleration. So if your graph looks like a roller coaster, congratulations, you are either accelerating or emotionally unstable. For example, a cyclist speeds up over time. The curve steepens. But what if the graph goes flat? Is it rest or is just existential crisis? Velocity is speed with direction. For example, speed, the car is going 100 miles per hour. This is speed because it is only telling how fast the car is going. Velocity is the car is going 100 miles per hour east. Velocity because it's telling the speed and direction the car is going. Acceleration, the car slowed down at the stop sign, then speed up. This is acceleration because it says the car changed its speed. So acceleration is change in velocity over time. Meters per second square is change in velocity meters per second over time in seconds. So if you are running east and suddenly turn west, that's acceleration or indecision. For example, okay, a car goes from 0 to 40 meters per second in 20 seconds. So the acceleration is 40 divided by 20, that is 2 meters per second square. Or a car goes from 20 until stop, until negative 20 in 4 seconds. So this is deceleration because it's going from a higher velocity to a lower velocity. Velocity negative 20, maybe means that it's going back. Let me know. Okay, so the difference is 40. So 40 divided by 4 is 10. So it's negative 10 meters per second square. That's deceleration. But what if the car was emotionally accelerating? Well, do we measure that in hertz brakes per minute? Let's talk about velocity calculations using kinetic energy because motion has consequences. Examples of kinetic energy is throwing a ball, riding a bicycle, moving car, and bouncing basketball. Kinetic energy is the energy an object has because of its motion. Depends on mass and velocity. Kinetic energy equal half mass times the square of velocity. Unit of energy is called the joule, symbolized J, capital letter, named for James Joule, a scientist. 1 joule equal 1 kilograms times square meter over square second. So, if you double your speed, your energy quadruples. Physics is the only place where effort multiplies when you are already tired. For example, a 2-kilogram ball moving at 3 meters per second has a kinetic energy of half times 2 times the square of 3, that is 9. So half times 2 times 9, that is 9 joules. 9 joules of energy, enough to power a very small light bulb for a moment. But hey, it's still motion. So we use the velocity versus time graph to find the displacement. Calculate the displacement between 1 and 4 seconds, for example, in this graph. The displacement is calculated by the area of the graph. So we calculate the area of triangles or rectangles in case the velocity is constant. Okay, so what is the area of a triangle? Let's take from 1 to 2.5, right? So that is 1.5 Half times 1.5 times 2 is 1.5. And then from 3 to 4, from 2.5 to 4 is another 1.5 times 2, wait, times negative 3. So half times 1.5 times negative 3 is negative 2.25. And then we add the areas. Is 0.25. So it means that after all this calculation, we moved only a quarter of meter. Okay, let's see another example. In case we have a constant velocity, like in the first displacement, we just have to multiply as a rectangle. So it's 1 times 10, that is 10. 10 plus the second triangle, the blue one, is, let's say, the 2.5 half times 2.5 times 10. That is 12.5. And then the yellow one is negative, right? So half times, that's 2.5 times negative 10. 12.5. The areas are equal. So if we add positive 1 to plus negative 1, will be 0, the total, right? So at the end is only the 10 meters, the result. Because it's 10 plus 12.5 minus 20.5. So it's 10 meters. Okay. So the displacement, we have learned that is the area under the velocity time graph. Yes, area, because apparently motion is also geometry. Now, challenging question. I wish you can answer in the comments, and then I will put a heart in the one who answered correctly. Car accelerates from rest to a speed of 30 meters per second in 5 seconds. It then travels at a constant velocity for 12 seconds. The car then decelerates at negative 30 meters per square second for 2 seconds. I want you to answer in the comments these 3 questions. What is the acceleration and displacement for each part of the trip? Find the average velocity for the entire trip, and draw the velocity time graph and the displacement time graph. Once again, write your answers in the comments. I will put heart to the correct ones. So, next time someone asks how far you have come, show them your graph. And say, I'm a triangle of progress. Note this movement, speed, acceleration, kinetic energy that we have seen is the energy energy an object has due to motion, like for example, meteors, walking, falling, throwing a ball, flying a plane, and so on. What truly matters is direction. Are we moving toward love, that is the real power, truth, and service? Or are we accelerating toward burnout and pride? As Proverbs 4:25 says, let your eyes look straight ahead. Fix your gaze directly before you. Let our motion be purposeful. Let our velocity be guided by grace. and let our acceleration be toward the kingdom. Now that we have mastered motion, it's time to design solutions. Because knowing how things move is great, but knowing how to move things for good, that's divine. Move like everything is gonna work out, because it is. Next up, tools, strategies, understanding, brainstorming, strategies, solutions, and systems that help us build, solve, and serve. If this made you laugh, think, or roll your eyes in scientific wonder, like, comment, share, and subscribe to the Learning Academy Foundation, where motion meets meaning, and the learning never stands still. See you next time. Bye.